So my name is Daniel Holmlund. I am from the Developer Relations Department at Intel. And first of all, I wanted to apologize to all of you. Yesterday when I came in, I was under the impression that this talk was going to be yesterday at 5 p.m. And I found the schedule and it said that, no, I was at 2:30. And unfortunately, that conflicted with the talk that I was doing just across the street at GMIC. And so we had to reschedule one of them, and hopefully we're going to get still a good turnout. But I want to apologize to all of you because of that. This session is on a system for authentication that doesn't use passwords. And you will have to excuse me too, because I've been at a booth all day, so my voice is just about done. So this system is something that was proposed only 3 weeks ago, so it's brand new, and it has caught a lot of developer attention right now. In fact, when I saw this, I actually canceled my previous topic that I'd been working on for a little while, and did this in favor of it because of two reasons. The first one was that I have a computer security background, and I really want to see the situation improve in web applications and mobile applications on the internet today. Today we've got a system that works fairly well, but it's got a lot of problems still. And there are a lot of ways that we're trying to improve it. And when I saw this, I thought this was a very novel concept, and I wanted it to get more awareness. So without further ado, boy, that is small. I'm going to pump up the size a little. Okay. So this talk is about SQRL. And the first thing I'm going to talk about is the username and password system and some of the reasons why it doesn't work very well today. And then I'm going to go into some of the ways that a lot of us have used, by us I mean technically savvy people, have used to make their passwords and other ways of authenticating stronger. And recently there's been a lot of multi-factor and secure ID ways of logging in over the internet. So I'm going to go over some of those. And then I'm going to go into, really quickly, just what are some of the features of an ideal authentication system. Not all the features, it's certainly not going to be comprehensive. They're going to basically focus on what SQRL does. Then we're going to go through and walk through what SQRL is, and the benefits of it, what the weaknesses are of it, and then go through some practical questions, because there's always a lot of questions on this. Somebody outside threw at me tickets here for free beer and said, tell the people that if they ask a question, they get a free beer at Jillian's. So I think I have 6 of these. So have at them. I encourage you to ask questions anytime you want during the presentation, and I'll stop and answer them. Although if we start to get bogged down, looking at you, no. If we start to get bogged down, I'm going to hold them more towards the end, because this practical considerations is just like boom, boom, boom. Here are the commonly asked questions.
I don't want the beer ticket, but what's your other topic?
My other topic was actually that Intel and Google were collaborating together to enable vTune, which is a profiling application, to run Chrome with a web application inside of it. And vTune would actually map from the JavaScript all the way down to the assembly code and give you a profile of your JavaScript application. So it's an interesting tool. I hear the Google Maps people are really the first ones to be looking for performance bugs using this tool. But so the upshot of that is basically that Intel's vTune system is now capable of profiling JavaScript. Okay, so first of all, starting with the premise that usernames and passwords are broken. And how many of you disagree with this statement? Nobody? Really? I would expect at least a couple people. Okay. So the first problem is on the server side. Nowadays, security breaches are extremely common. You hear about them all the time in the news. When you get a security bulletin or if you're doing your monthly, Patch Tuesday cycle, if you're using Windows, or if you've got a Java system backend, these problems are abundantly evident. They list them out for you. I think that the last Java update patched 50 remote exploitation security vulnerabilities. So that's 50 ways somebody can basically compromise your system over the internet. And they make large headlines as well. These are just a couple of the headlines that I could find really quickly by searching. One of the fun ones to talk about was how the Ubuntu forums was broken into and all the usernames and passwords are stolen from there. Instead of a forum sign, this penguin with a machine gun showed up and said basically all your passwords belong to us. But in a more serious note, there are break-ins that affect healthcare systems. So there are break-ins that affect lottery systems. The PlayStation Network was famously down for a significant part of 2 months last year. And in that particular case, they were also found to be legally liable for the damages that were caused, and they were fined. I believe it was $400 million approximately they had in fines. So not only are security breaches opening you up to identity theft, but it's also opening the server side, the company that's implementing it, up to all sorts of liabilities. Excuse me. Oh, another famous incident was the RSA break-in. RSA doesn't talk about it very much for obvious reasons, but the break-in was dated as of March 2001, where they possibly had their master keys stolen to a large portion of their secure ID system. So with today's operating systems, we all know that security breaches are very common. And even if you are a great administrator, the operating system itself has underlying vulnerabilities that are open for exploitation. So breach happens. We should expect security breaches, and any authentication system that we're looking at should be mitigating against having our identities stolen if a system is compromised. So the question that, or one of the questions that SQRL solves, or at least attempts to solve, is it possible to build an authentication system where the website has no usernames and passwords to lose? And this would be following the trust no one principle in security. It's a really famous principle. It's been around for a long time. But trust no one basically says that if you have a third party involved in your security transaction, or if you're trying to keep your data secret, you don't want to send it out to the internet before encrypting it, trust no one means that you are the only party that you can trust. So problem number 2, the users. And this, I want to underscore, is not who I want to blame for this. I actually blame the system that they're using in usernames and passwords. But we all know that people use their password on most every site they are on. Or maybe you have 2 systems. Maybe you have a secure password and you have a throwaway password. My throwaway password is the word wonder, W-O-N-D-E-R lowercase. And I don't care about that because those are all sites that I'm not particularly interested in securing. But a lot of people use passwords like that on their banking sites, or on their healthcare sites, or their system that they use to log into the corporation that they work for. And so once a system is compromised and your username and password stolen, of course, identity thieves and other types of people that are after your identity are trying that on your Facebook account, your Twitter account, your bank account, anything that they can break into. So passwords are hard to remember. That's why people do this. And people do silly things like write them down and attach them to their monitors. I don't particularly blame people for doing this, but it happens. It's part of a system that it makes it difficult for people to remember how to authenticate themselves. So I wasn't sure if I should qualify this list or not, but this was a list of the top 10 ways that people construct their passwords. And I was a little surprised when I saw the source and was wondering exactly how they collected the data, but which I don't know. But the top 10 reasons they have here are, or top 10 ways that people make their passwords are through their pet's name, significant dates like a wedding anniversary, the birth of a close relation, your children's names, other people in your family, your place of birth, your favorite holiday, your favorite sports team, or your spouse's or current partner's name, or just the word password. So this opens people up to social engineering attacks. This opens them up to extreme guessability. This opens them up to password cracking. And the top 3 passwords of the year 2011 were password, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. Also coming up were baseball, I love you, 6 ones, and Jesus and ninja. And password 1 was also high on the list.
Because some people throw away passwords.
That could be. It could be. Yeah. Yeah. You just have to be careful where you do that. So other problems, malware. Nowadays, I need to stay close to this. Nowadays, viruses are being made that will specifically infect a system and lay dormant on the system until a specific activity happens. Say they log into their bank. And these are the reasons why I don't use, I actually use my Chromebook to do all my banking. But I certainly would not want to do banking on, for instance, another machine that I commonly have on the internet in places that where you might get viruses. So a lot of these viruses, for instance, there are viruses that will infect a system and then lay dormant on the system waiting for a session to be established to a bank. And when they see that, they'll proxy your connection through the local host and use your authentication credentials, log into your bank account, and begin transferring money or doing other things while then presenting you with a false page. And viruses like this are becoming more and more common. They steal your credentials and do things behind your back. Malware also includes, going down to your local library. No one in their right mind is going to log into their bank account at the library terminal because you never know what's there. There could be keyloggers, there could be viruses, there could be anything. Another security problem is those people that are actually legally allowed to take your username and password, and that is corporate firewalls. Oftentimes, if you have a machine that's given to you by your IT department, it'll have an SSL certificate that's on it that allows it to decrypt outgoing SSL. So these authentications, any authentication that happens over SSL traffic in that sense is open for sniffing by the corporation. And they have the perfect legal right to do that. Keyboard loggers. I mentioned this briefly. They can be hardware-based or software-based. I'm going to go through this a little bit quicker. So, like I said, coming on here, usernames and passwords are a system that has worked very well for us, but it's got a lot of problems. And I don't blame the users for this. I think it's actually the system itself that is at fault. So what have we done in response to this in order to strengthen the security of our authentication systems? And there's been a lot of these. First of all, I have to show my obligatory XKCD cartoon here. If you can't read this, or if it's cut off on the bottom of the screen, basically what you have here is a password that is troubadour, and it's substituted the O's for zeros, and it's thrown in a couple of punctuations, the ampersand, and over here it says that we're getting about 28 bits of entropy on this password. And the user is sitting over here scratching their head wondering, what was my password again? I can't remember. And so down here we have correct horse battery staple. And we show that instead of having 28 bits of entropy on this password, it has 44 bits of entropy, and it's easy to remember. Now this is a example. Now unfortunately, if you use a password like that, you're opening yourself up to dictionary attacks pretty easily. So even though there might be that much entropy in it, you can easily guess the words that are involved in it. But this is a way of strengthening your password, and more people are doing it. So that's my shout out to XKCD. More companies, hopefully all companies, should be salting and hashing their passwords. When break-ins do occur, hopefully the company is sending you an email that says a break-in occurred, but we've encrypted your passwords, we've hashed your passwords, and so you need to change it, but there shouldn't be any loss of information. Sometimes you get an email that says, oh my God, change your passwords now on all your sites. And you don't want to get that. I also am somewhat disturbed too when I try and use a very long password and the site will come back to me and say, no, you can only use 12 characters. Sorry. Or you can't use punctuation. That happens a lot more than should happen, and it's usually because they've got a back end that's older and it's running on older hardware or older software that can't handle larger passwords or larger character sets. But to me, it also says that they're not hashing their passwords to fixed links. I mean, whether I put in a blank password or I put in 64 random characters, they should be hashing it. And if their back-end system needs to truncate the hash, I'm not saying that's great, but they should be accepting any size password because it can be hashed. Most sites are enforcing somewhat stronger password policies. So you'll see this in your banks. More and more banks are saying you have to add in punctuation, you have to add in numbers. Everyone's seen this. And it's good that there is more awareness of passwords being needing to be strengthened. So password managers, I don't think this has actually hit the mainstream of users. Maybe it has to some extent. And there are a lot of password managers out there. This is just the one that I use, so I put it up there. But this will store all of my passwords. It will keep it encrypted on my disk. And when I go to a site, it'll enter in my username and password for me. So this is great because, at least for me, I use a random 64-character password whenever I can. Usually the exceptions to that are when the site doesn't allow it, or whether it's like something I have to enter into my mobile device numerous times. So password managers are good, but they're not ubiquitous. I can't enter in my Apple ID, for instance, on my iPad very easily with LastPass. So multi-factor authentication is becoming more and more common. I'm just going to throw all those up there, not talk about them very much. But passwords, pins, and patterns are all forms of something that you know. First of all, multi-factor authentication is the idea. It was actually a government standard. I forget which document that it was put out in, but it was a government standard that said that we need to authenticate people by having at least two of these three items: something you are, something you know, and something you have. And so examples of something you know are passwords and pins. Banks use pins all the time. Your Android devices or other devices often use patterns. And these are somewhat secure. Mobile phones, something you have. So a lot of times, if you're using Google Authenticator or you've got a second factor on your Apple ID account, you will be sent a PIN number. And it will arrive to your mobile phone via SMS or some other way. And that just authenticates that you actually have a phone, and you both have the phone and you know your password. Will usually be the two forms of authentication. Smart cards. I remember when I was, I don't know how old I was, probably a teenager. My dad came home from his job at Hewlett-Packard, and he had this funny credit card-sized thing that changed numbers every 30 seconds. So this was secure tokens. And secure tokens are basically a way of synchronizing a shared secret that's both on the client side and the server side. That's one other way of testing something that you have. And USB dongles fit into the same category. Now, something you are is a little more tricky from a security perspective because it allows you not only to authenticate yourself to a third party or the person in the transaction, but it doesn't give you any deniability. It allows the third party also to authenticate you, even if it's against your will. So that's why I'm a little wary of things like fingerprint readers, retinal scanners, and DNA scanners. You'll find these in a lot of installations. Well, for instance, if you are arrested and you go and you're being jailed, they're going to take your fingerprints. They don't sit you down and say, okay, sir, please come up with a password. We're going to identify you with this in the future. Because the password is something that authenticates you to them, but a fingerprint allows them to authenticate you, and vice versa. So something you are doesn't have any way of being changed or revocated. That's why they're good at government facilities or other high security facilities as well, or in connection with law enforcement. We looked at security tokens. I wanted to mention the YubiKey here, and there are other keys like this. This is a USB keyboard that generates one-time secure passwords. And you can set these up to work in conjunction as a second factor of authentication with LastPass or with other services. But these are great ways of coming up with new passwords and using them to authenticate yourself to services. But the problem is that users don't use any of these. They use Wonder as their password, or Monkey, or maybe a stronger password. But it tends to be only within the tech community, or if your company is forcing you to use one of these, that a person will use these. So, what are some of the features that SQRL has, and how does it address the situation? I'm going to go through these really quickly because after I explain how SQRL works, I'm going to go revisit them and talk about how each of these works. So there's no shared secrets with SQRL. Shared secrets, like a password that's known at both ends, were a long time, back when symmetric keys were being used a lot. The RSA, the founders of RSA came up with asymmetric keys, and an asymmetric key is basically a public key and a private key. So in this particular case, you don't have a shared secret. So shared secrets can be replaced by public and private keys. Anonymous identification. I'll talk more about that later. SQRL supports multi-factor authentication. Excuse me. It maintains a strict separation of identities. So in other words, if one particular site is compromised, the authentication credentials that are used there are not going to be able to used on another site. And there's no third-party involvement. So it's directly from the user to the person that you're trying to authenticate yourself to. There's not a Facebook or a Google or a Twitter in the middle, and there's not an NSA in the middle, hopefully. But there's no third party that can be legally compelled to hand over your authentication. SQRL doesn't use a keyboard. And SQRL is very simple to use. So this is where I give credit where credit is due. SQRL was announced about 3 weeks ago by Steve Gibson, who is one of the hosts of the Security Now podcast. He introduced it, and at this current time, he is looking for feedback on the system. He's proposed the system. It looks to be an interesting system, and that's why I'm talking about it here, because I want to help people not necessarily to think about SQRL, but just to think about authentication systems in general. How do you build something that's more secure for the end user and that doesn't lead to security breaches that compromise the end user? SQRL does seem to be an interesting system, though, so that's what we're going over here. Steve Gibson also coined the term spyware. If you listen to Security Now, you've heard these all a million times. I enjoy Security Now quite a bit, and I listen to it. He's the author of SpinRite, and he is a host with Leo Laporte on the Twit network. So, user account logins. This is what it looks like from a user perspective. So the user will launch their smartphone, the authentication app, so the SQRL application, and will point it at the QR code. Actually, this may not be strictly true. If you've got Android Intent set up properly, you can use a regular barcode scanner just to scan the QRL, and then it will bring up the authentication app. But you can bring up, either way, you scan the barcode, and then for verification, SQRL's authentication app is going to display the domain name on your smartphone of where you're trying to authenticate to. And you need to make sure that they match. And after verifying the domain, the user permits the SQRL app to authenticate their identity, leaving the login information blank they can just click log on, or if there's a bit of AJAX going on in the background, once the authentication on the background is received, you can send a message, a push message down to your web application to log the user in. So I would highly recommend you give them some sort of feedback, you know, a green light, you're being logged in, and then log them in. So here's an overview of the SQRL system. This is the graphic that's directly up on grc.com, and you'll find this graphic in their news groups quite a bit. It's the graphic that I'm going to use to explain most of this presentation here. The only one difference in this graphic that I would say is that up here where it says HTTPS, it should be SQRL. That's the only difference. Excuse me. I know I can't get away from coughing into the mic when I'm wearing it. So, the first step here is that the server is, the user goes to the server is going to respond with a page that has a QR code on it. This QR code is presented probably near the login prompt, or wherever portion of your page does that. The URL includes a securely generated long random number, and the SQRL community has termed this the nut. Originally it was called a nonce, but a nonce is actually not quite the correct term for it. A nonce is a number only used once, but it doesn't have the property that it's non-guessable. In this particular case, you need to have a randomly generated number or string that is not guessable. So it needs to come from a random number source. And that random number source, the entire URL, all the way from the SQRL, or the HTTPS, all the way to the end of the cryptographic challenge is going to be encoded into the QR code. So once the QR code is read, the smartphone is going to use an HMAC function to cryptographically hash the domain by the user's master key. An HMAC function, for those of you who doesn't know, takes a message. In this case, it's the domain name, and it takes a private key, and it uses that in order to create a message authenticated code, basically a hash that represents a way that you can verify the domain and the person who generated it. So these are going to go into the HMAC function, and the HMAC function, the private key is 256 bits. The HMAC function also spits out 256 bits, and that becomes the user's private key. So after the user has a private key, depending on which crypto system you're using, you can actually generate your public key from your private key. This isn't true for all crypto systems. For elliptic curve, it's true. It's not necessarily true I don't think it's necessarily true in RSA. But the property that you're really looking for is that you don't want to be able to derive the private key from the public key. Deriving the public key from the private key is fine. And this actually, if you're using elliptic curve cryptography, is very quick. So it's a quick operation. Once the private and public key are both created, you're going to take the entire URL with the cryptographic challenge and sign it using the private key. And then you're going to send the signed signature and the public key back up to the server, or to whatever authentication service they have going. So what this does,
You're sending what when? I mean, what part of this is a browser on a computer and the other part's on a cell phone?
Right, yeah.
What's sending what here?
So the server side ends pretty much at the long red line that goes along the top. The server is going to generate the cryptographic challenge. It's going to encode it into a QR code. Actually, you could...
On your laptop.
What?
That's sent to the browser on your laptop.
Yes, and then that page will be displayed on your laptop or other device.
Correct. Next step is to take a picture of it.
Yep.
And then that's sent by your phone up to the server.
Yep.
Okay.
It requires two devices on client side, right?
There are actually ways you can make it require one, and that is if you're not using a QR code. So if you encode the data into a link itself, you can just touch the link or use your mouse to click the link. But in that particular case, you're using one device, not two. So you're missing a couple of things, like a second factor of authentication, but there are ways that you could arrange this so that you don't need a second device.
So if you're using your phone to log in, and that is your normal device, but you happen to want to just see that page, there's some sort of plugin in the browser that reads that link and redirects you to the...
Yeah, that's exactly how it happened. When you click on the SQRL link, it would be recognized by a plugin on your browser, or perhaps an Android intent. If you're on your phone and you click on the link, would bring up the authentication application, and it would be processed by that, either the plugin or the application. So.
Okay, but your phone must have a certificate.
Yes, it's got the master key. No, not an Intel certificate. No, the master.
Third-party certificate.
No, the certificate is created. I'll show that in a later slide. Basically, you use a source of randomness and another. You don't want to rely on one source of randomness. You use multiple sources of randomness. One source of randomness is you might just turn on the camera on the phone and wave it around like this, and then merge that in with a randomly generated number to create your key. So it's not an Intel certificate, it's not a third-party certificate, it's created on the phone or device itself from randomness.
Rest as a certificate on your phone, or do you create a new certificate each time?
Both.
No,
Yeah.
you cannot create so extensive.
So the master key rests on your phone for all time. That's your master key, that's the root of your authentication. After it's gone through the HMAC here, you're creating a private key, public key pair that have hashed into them by the HMAC function the domain that you're using. So it's a unique private key and public key for each domain that you visit. So those are created on the fly and not stored on the phone. And the reason why it can be done on the fly is because elliptic curve cryptography is very quick at generating those keys.
It's widely believed that the alphabet soup can breach these on a moment's notice. So what happens if your master key is taken off your phone?
Okay, I'll get to that, okay? I'll jump ahead in the presentation. Was there a question over here?
So, can I use a different phone than the original phone to log in? Or can somebody use my phone to log into the system?
We'll get to that too.
At least for listening.
Yeah. They have some beer tickets out here to hand out. Come see me afterwards. So okay, I already talked about this. Once you've signed the cryptographic challenge with your private key, you send your public key and your signed crypto signature to the server. So the benefits of this system, really quickly, is that cut off? Yeah. Okay. Visitors to a website are uniquely identified by an anonymous 256-bit number, which is their SQRL ID. This is actually just the public key we sent over. So when the server receives this public key, that's what's going to let them know which user it is. The same visitor, no matter how many times they come back to that, is always going to have the same public key generated. And the reason why that is because each time you run the domain and the master key through the HMAC function, you're going to generate the same key. So that same key is always going to be generated for this site.
Why? Why is it always going to generate the same key? What if they change their URL or something?
Well, it's only using the domain name, so it is locked to a particular domain name. It's not using the full URL. One nice effect of this is that the first time that you log in using this, the server can create an account for you on the fly. So rather than going through the whole steps of coming up with a username and password, sending it to something you have, which is your email address, second factor of authentication, and then verifying it on your email address, all you need to do to initially set up an account with SQRL is just take the picture of the QR code. Now this confuses a lot of people, and over here I have, somewhere over here I have that it's anonymous. Because it is anonymous the first time you log through. And I kind of liken this to if you've ever gone to the DMV or a pharmacist and they've got a ticket you pull. So you go up to the ticketing counter and you pull a ticket and you're number 42, of course. And so you take this ticket and you wait for your time to be called up. When you go up to the counter and present your ticket to the person, they see your number 42, you've just authenticated yourself and that you belong up there, but you're still anonymous. So it definitely is possible to have both an authenticated user and an anonymous user. And we see that all the time, at the DMV or other places. Of course, what's the first question that most, you're going to be asked as soon as you get up there?
ID.
Yeah. Can I see your ID? What's your name? And so at that point, you're no longer anonymous. And of course, websites are most likely going to do that. They'll set up the account and then add a username or some other ID to it. But they don't have to. If the site was security conscious and they wanted their users to be anonymous, they could remain anonymous. I've already mentioned that SQRL IDs are user and site specific. There's no shared key.
Are they device specific?
No, they're not. So, and I'll talk a little bit more about that when I talk about exporting the master key from one device to another. So we'll get to that. So there's no shared secret. The shared secret is always, the private key always remains on the phone or device that is the second factor of authentication. And the public key is what's sent over. So even if there is a breach on the server, the attacker is only going to get the public key, which is well known to everybody, or can be made well known. The only mode of interaction that uses the QR code is keyboard free. There are definitely times when you want to, and I'll talk about it later, when you will want to add a password to it before it allows you to access the master key. Out-of-band communication. So this is a fairly well-known principle in security, and that is you don't necessarily want to do all of the transaction or all of the authentication through a single channel. Say, for instance, you're on a library computer and you want to be able to log in. Well, the library computer can show you a QR code, but as soon as you take a picture of it, you're doing the authentication on an out-of-band channel. And that can be used to authenticate to the site even if there was a keyboard logger or other device sitting on the library computer. So the idea here is you don't want all your authentication to happen through one channel. And it does support multi-factor authentication. You could add like a YubiKey or some other device to the system, and your phone itself is a second factor as well. This is my favorite part. There's no third-party involvement. So it's just you and the server you're authenticating to. You're not authenticating yourself to Facebook, Google, Twitter, or some other OpenID service. You're not authenticating yourself to a company or organization that could be compelled legally to give your account identification over. And it's a simple user experience. You just take a QR code and log in. There's less IT support as well. IT is constantly told to reset your password, and there's a lot of account management that IT does, and so this I think would lessen the IT support. Although if you are in IT and want to tell me differently, I just threw this in there thinking that it was true. Yeah. Okay. So on the server side, how's my time doing, by the way? Oh gosh, okay. I'm gonna go through a little quicker here. Hopefully it'll be clear. On the server side, you're going to be generating a URL that looks like this. A little bigger. And this URL is going to have a scheme. It has the SQRL scheme. Or if you don't want to do it over an encrypted channel, it could have a QRL scheme. These are just conventions that have been initially proposed. The specification is in total flux right now, and it's being hotly debated on the GRC news groups. But this is what's been proposed. The domain is the portion that you use with the HMAC function in order to create a public-private key pair. And there is a query separator, and after the query is the cryptographic challenge that is used. Basically, it's not a session ID, but it's used to establish that the person who took the QR code is indeed the person who looked at the QR code. So the authentication comes from the person who looked at the QR code. we're going to go through this a little quickly. One thing that you have to keep in mind is that URLs are case insensitive. However, hashing functions are not. So all QR SQL URLs should be lowercase. And there are parameters that go along when the query is submitted back up to the server. And those parameters that are tacked on are the QRSQL version number, a options argument, which if you want to learn more about that, you can go read about it on the news groups. Basically, there's only one argument that's been proposed so far, and it's to avoid man-in-the-middle and phishing attacks. Your QRSQL public key and the old public key, and that's another topic I'm not going to talk very much about, which is key revocation. So you can look that up too. The string needs to be assembled in a text buffer exactly like this, and the QRSQL Authenticator application is going to sign this entire string. And so it needs to be exactly this string and not a different string or leaving off some portion of it. So we're going to pass this through a cryptographic function and send it to the server. One option inside this is a vertical bar. A lot of sites will authenticate to a certain subdomain, or will have an account bit of information that's in there. This is common on GitHub and on a lot of sites. And so if you put a vertical bar in there, the domain name is lengthened to include everything on the left side of the vertical bar. And that information goes through the hash function in order to generate your public-private key pair. So most of you, I'm assuming, are probably not going to write authentication applications for the smartphone. You're interested in implementing this on the server side. Am I right there? Yep. Yeah, okay, good. So one topic that's been very hotly debated in the news groups is whether a bit of pre-authentication information should be stored on the server before the actual authentication comes around. And it's a little hard to visualize this, but basically when the QR code is generated, the server is going to need to know some information about that QR code so that when the information passes through the Authenticator app and is sent back to the server has a way of connecting together that this is the session that belongs to the person. So because the server receives the authentication from an out-of-band source, it must match the authentication up with the proper user session. It may do this by setting up some state on the server side or encoding that state into the actual cryptographic challenge. So it is kind of a misnomer to say it's stateless. What we mean there is that the state is not held on the server side, it's held on the client side. And I should have looked at this here. Here's the cryptographic challenge. So like I said again, one way is to actually encode the information into this challenge. Another way is to store a bit of information on the server side and wait for the authentication to come back around. The nut must be unpredictable. So the cryptographic challenge, I don't know why I was on Shutterstock and I typed in unpredictable and I got nothing but pictures of yaks. So the nut must be unpredictable. Otherwise, people will be able to guess and hijack your session. Yeah, yaks. Okay. When the server displays, so creating for a stateful login, if you have some bit of pre-authentication login state, you probably only want to keep that around for a certain amount of time until it expires. Otherwise, you're going to be creating a table of state that just grows continuously. So it's only valid for a certain amount of time. And if you do store the state on the server side, you're free to use a hashing function in order to encode the nut. And hashing functions are one-way functions. So basically, if you hash it, you're not going to be able to pull any information from that hash when it comes back around on the authentication. If you want to encode in the data into the cryptographic challenge itself, you need some way of the hash, or you need some way of it being reversible. So in that particular case, you can use AES or some other encryption, block encryption. So this token, if you do want to, okay, so I've already mentioned that state is stored on the server side and waits for the authentication to come in. One thing that you should know is that the data needs to be passed through a base 64 encoding, just because not all servers and not all clients are nice to non-ASCII characters. So this is a way of protecting the characters in the URL stream. And I'm going to take a moment here to talk just slightly about the Intel random number generator, because I know there's a lot. I've heard people say that maybe the NSA has compromised the Intel random number generator. If they had, I wouldn't know of it, but from the technology, I kind of doubt that. It's not a pseudo random number generator. And even if it was compromised, you can always use multiple sources of randomness. So even if the Intel generator was compromised, there are still ways of creating good sources of randomness. But I don't think that it's compromised because the random number generator is called a TRING, a true random number generator. It actually uses samplings of thermal variations inside the circuit in order to generate its randoms numbers. So instead of seeding a random number value and having generate a string of random numbers, which given the same seed would always generate the same string of numbers, it's actually sampling thermal variations within the circuit, which are, they're on a very small level, quantum levels, and they're random. And so that's the source of randomness, starting with Ivy Bridge and then also in Haswell.
Actually, by definition, you cannot hack random. It's a random. How you can hack it? By definition, it's a random. How you can hack it?
Yeah. Well, okay, so to elaborate on that a little bit more, the random numbers, when you're using thermal fluctuation, can't be generated fast enough to actually meet the demand for a random number stream. So you can only generate at a certain rate when you're sampling physical quantities. So these random seeds are used as the seed for a pseudo-random number generator. So you sample the seeds, which are random, and that's used to seed a pseudo-random number generator. There's a lot of information for that up on intel.com. Okay. So creating the nut for a stateless session, these are just proposals that were added to the GRC news groups. But if you don't want to store your state on the server side, you want to store it inside that cryptographic challenge, you need information in order to connect this session up. So pieces of information that you can put in there would be like the IP address, the current timestamp, a counter. So this would be a nonce, so you can protect against replay attacks. And you want to encrypt that with something that is reversible, like AES. These are only suggestions. They're not hard rules.
Does the security system require the server people to come up with good random nuts?
Yes.
Okay.
Yeah, absolutely.
That's a typo. High-speed public key.
What did I say?
The next one.
Sorry. Okay. We'll not dwell long on this slide, but elliptic curve cryptography is chosen for a number of reasons. And some of those reasons is that it generates very fast signature verifications. It signs very quickly. It's fast key generation. It's fast. That's the bottom line. And the second bottom line is that the signatures are very small. So the signatures can be 64, 32 bits, and the public keys are very small. So the reason why the signatures and the public keys are small as compared to RSA is because RSA is using the number factorization problem as a hard problem to generate its keys. Elliptic curve cryptography uses elliptical curves, which is a a harder problem to solve. So in a smaller key space, you actually get a larger amount of, you need a larger amount of computational power in order to break it. So you can shrink the size of the keys for that reason. The other reason that this particular system is being used is that this particular system was talked about hotly in academia and was generated by a couple of cryptographers, one of them being Daniel J. Bernstein. And this standard did not go through a standards organization and did not have members of the NSA sitting on their boards or on the committees. So one of the Snowden revelations that's come up recently is that the NSA has put people on a lot of the committees that come up with cryptographic standards, and the speculation has been that they've introduced backdoors and other things. This is, take it for what it's worth. This is a system that did not go through that. Intel has instructions for accelerating AES. And they're standard on all Intel processors. So if you're on the server side and you want to implement this, make sure you're using a library that uses these sorts of functions. You can drastically lower the amount of time it takes to sign keys and generate keys, and do the verification when the authentication comes back around. Details on the client side. I'm running out of time, aren't I? Yes. Details on the client side. So I'm not going to go through in huge detail. I'm going to go through this kind of quickly. But if you have a master password on your phone and you lose your phone, you have lost your identities. So this system here in red was added on to include a PIN number or a password that needs to be used in order to make your master key usable. And the way this is working is that you have an identity password that comes in here, and it's put into a function that that's called a I'm blanking. It's a function that will take a password and blow it up into a block-sized string. So it's expanding the password to a fixed size. In this particular case, we want 256 bits. And then you XOR that with your master key. The reason why we're XORing it is because XORing is an easily reversible operation. So if you say you've got a 1 coming over from your master key, and you type in a password that causes a 1 to go up here, the thing that we really need to remain constant is this key right here that's moving into the HMAC function. So if you change your password, we can, and so that 1 becomes a 0, that 1 becomes a 0, we can go and alter the master key so that the XOR operation maintains the same key going into the HMAC. So it's simple to modify the master key to emit the correct value going into the HMAC while still being able to change your password.
So what if you will store the master key on your SD card to share between phones?
So I may not get to this, but it is in a later slide. Basically, you can take your master key and export it using a QR code. And before you actually before you put your master key into a QR code, you want to make sure that it's encrypted and the QR code is an encrypted version of it. And so you can take that and scan it in between devices. The thing that's been recommended for exporting your master key is a memory hard function, or a time-consuming function. So say you encrypt it for 60 seconds or 30 seconds, and bring it over to the other phone and have it transfer over decrypt for whatever amount of time. That means that if you have an attacker who's trying to guess your password, it's going to take 60 seconds each time. Actually, I'm sorry, your password, you may only want a half a second of computation. In actually exporting your key, you might want something longer. I'm going through that really quickly, and I'm not going to have time to get to the slide. But the idea is that you want to make it difficult for people to guess your password, but you still want to be able to export it. And you can do that just through a QR code. Okay, generating the master key. I mentioned this briefly. It should use more than one source of entropy. So you can use your device's random number generator. You might also enable the accelerometer and have people shake it, or turn the camera on, or do both. And you can move those together. Again, random number generator on Intel tools. You can combine it with accelerometers. And once you get all this information, you need to actually use the same function that blows up your input password. You need to put it through a hashing function that produces a fixed size value. So you have a 256-bit key. I've already talked about XORing, so I'm going to go through this quickly. Verifying the password. So what I've talked about so far allows you to combine a password and a master key, but it doesn't necessarily verify it. So what you want to do is that when you've combined the two, set aside some portion of it in a verifying area so that when it's generated again, you can verify that it's the correct password. And I do apologize for going through that quickly. Scrypt is the function that they're using here in order to make the identity password a 256-bit size. Okay.
Can I use my fingerprint reader to create the password on my laptop?
I wouldn't necessarily call that a source of randomness, but you could.
No, not a key, the password.
Oh, for the password? Oh, sure, sure. If you have some way of digitally encoding that so you can XOR it with the master key, sure. So one big potential problem is malicious QRL codes. What if you log into yahoo.com and sitting there is or what if you're on some site that you don't want to, yeah, basically if the QR code doesn't match the domain that you're currently on, if you're at xyz.com and they show a QR code that has the URL yahoo.com put onto it, they can effectively do a phishing attack where they take your credentials for yahoo.com. That is why when you snap the QR code, you do have to verify that the QR code decodes the domain you're looking at. So that is a big potential problem, and there's a lot of discussion on that over at GRC. What if my master key is compromised? Don't let that happen. In all seriousness, that's a big problem with this system, and it's probably its main weak point. But if your master key is taken over, you basically need to go in there and perform revocation on each of the sites, and you need to you lose control of those accounts. Huh? And that's why you also want to have the password too. So you do need both the password and the master key in order to do that sort of compromise.
What is more secure, SQRL protocol or HTTPS protocol?
Well, they do different things. So I mean, they cover different areas. We could talk more about that later, I think. Okay, what if I lose my phone? Do you want a password? What if I don't want anonymous users on my site? We talked about that really briefly. As soon as you give that ticket to the counter at the DMV, they're going to ask you for your driver's license. It's the same thing that happens on a website. As soon as your session is authenticated, you probably want to ask for their email address or something else, their credit card, who knows. What if I want my phone to log into a site? So I'm surfing on it, and we talked about that a little bit earlier. So if you have a QR code on your phone and you can't use another phone to take a picture of it, then you can also click on the link, and that will activate the SQRL authenticator on the same device, whether it's a browser plugin or another application. What if I don't have a smartphone? Same thing, you can click on the link. How are identities backed up and or cloned to other devices? I really quickly went over that with you. You can encrypt it and code it into a QR code, and then that QR code can be transferred from one device to another. You just want to make sure that the amount of encryption time it takes is significant so that if somebody else captures your QR code, they can't try and find the password you used by trying every password combination.
Laptops or phones or any other place, or just phone to phone?
It could be any device.
Okay.
Yeah. What if I want to revocate my login credentials for a particular site? There's lots of discussion about this over at GRC, more than I could possibly summarize. And are there any known SQRL implementations? So these are all implementations that are basically prototypes. Like I said, this technology system was only described 3 weeks ago, and 3 weeks ago and 6 hours. And so these are prototypes that people in the news groups have put together. And here's a couple of libraries. I was not exhaustive on this. That'll help you take a piece of data and turn it into a QR code. So in case you're wondering how to do that, there are libraries that can do that for you. Whether it's on the client side or the server side, if you do it on the client side with JavaScript, you do open yourself up to other malicious JavaScript being on the page. So I do recommend that you generate these QR codes in memory on the server side. Okay. We hardly have any time, so if you want to ask questions, do you guys want to sit here for questions? Whoever wants to go can go, and then those who want to have questions can stay.
One of the solutions this was for was to simplify it for people who don't need to remember the names, passwords, simple passwords.
Right.
How are you going to get end users to use this then?
If they need to remember a password still?
Well, yeah.
Okay. So, yeah, the one reason why it's better in that respect is that each public key, private key pair is different per site, and you're only entering in one master password.
But what if their master password is password?
Yeah,
See,
that is a problem.
All right, thank you then.
Since the master key is decoded by password, does it mean every time I try to log in, I still need to enter the password?
Yeah, it doesn't necessarily mean that. You could log in once and then have it time out after a certain amount of time. Well, assumably, you'd only keep it going for a minute or 30 seconds. If you handed it to somebody else immediately, and you said that you didn't want it to ask you for your password again for 1 minute, then. Yep.
Okay, so the question still stands. What is a more secure way to use this system? So via SQRL protocol or via HTTPS protocol?
Yeah, the two aren't exactly equivalent. So I mean, you want to use.
You can use this by 2 ways: by HTTPS protocol or
by SQRL. So any post that you do back to the server should be HTTPS. But the whole system of generating the QR code, the random number, passing through the authentication, that's SQRL. So the SQRL is meant to inform your device that you need the SQRL authentication application. But communication to and from that app and the server should be HTTPS.
Okay, like engagement, it's a SQRL protocol, right? But the other communication is HTTPS.
Yeah. Okay. This gentleman over here.
2 questions. Multiple accounts. Do the clients on the phone support that? And is there any sort of developer option if I need to log into my laptop as local host to kind of skip all that?
Well, those would be implementation details. The system certainly could use multiple usernames. You could have multiple master keys. That's not a problem. What's that? So the Android client that's out there is just the barest of code. Like I said, it's 3 weeks old. So I did see somebody who was doing an Android native. So all the crypto was done in C using the NDK, the native development kit. So that does exist, but as far as I could see, they were focusing mainly on the crypto portion of it. There was no usable user interface yet.
And so for local host, I assume you just want to use, for development testing, I assume you just want to click on the computer and use your computer to log in.
I mean, you can encode an IP address that's on your local area network, but you could just click and do it localhost too. Yeah. I think this gentleman was next.
I had a couple more questions about the stability of the specifications. You mentioned there's been one release 3 weeks ago, so a couple aspects of that. Has it gone under any sort of formal academic review?
Nope.
And, okay. Is the specification stable? It's enough to produce
Nope.
a complete implementation? Is there a plan?
Basically, it's like a request for comments. It's been, well, maybe not exactly like that. It's been put out there, and the author is asking for feedback.
Okay, so all these prototypes are not necessarily interoperable.
No, they're not.
Okay.
Hopefully they will be, but they're not now.
Right.
Question: how can this authentication method go through a proxy server if I want to visit a resource through a proxy server? Is the domain name can be different, or is the proxy server that generate? Will the proxy server will generate master key for me, or what?
The domain name of the URL is, or whatever the server decides. Basically, the server needs to encode into the QR code the location of where it wants to receive the authentication. So as long as those two things match up, a proxy server in the middle, I don't think would have an effect on it.
I see two potential vulnerabilities in this thing.
Just two?
Well, two biggest
Okay.
potential vulnerabilities. One is hijacking the public key, which allows the third party to log into the site in question without the credentials.
That's why you want to password it. That's why you want to put a password.
If you hijack the public key, you don't have a password. Public key is the password for the website.
No, actually, you use a combination of a password and a public key together in order to authenticate yourself. The password is optional, but you can combine the two in order to create.
But when the public key hashed over with the password is sent over the wire, that's the thing that the server is used to authenticate. If it is hijacked and replayed, that will be the same forever, right?
So the cryptographic challenge that is sent from the server needs to be different every time.
Sure.
And so when that's encoded by your private key and your public key, you're going to have a different signature along with your public key.
Okay,
so each time, the combination of those two will be different.
Okay, so if the cryptographic challenge is encoded into that, then that vulnerability is off. What are the ideas right now to prevent the if the master key is hijacked, this clearly breaks everything. Is there any work right now to, if you know that your master key has been compromised, to do anything about it?
Yeah, there's a lot of discussion. It's all discussion at this point. But if your master key is compromised, the best suggestion that I've heard right now is having the password that you can XOR with it. So having the two of those together, something you have and something you know. If it's entirely compromised, then there are a lot of issues that are yet to be worked out. But that's the same. One thing that is
change the password.
Yeah, you can change the password if you've enabled a password. It doesn't need to propagate because it's all done on the client. So that combination of the password and
authenticated server and client.
How is this authentication
It's
system
like a regular password.
associated with the authorization system?
Okay, it's a
user has certain set
the
of
same
privileges
application like with
set by
password,
an
but
admin.
the randomization is added.
So
that
that
is a
has
simple
been done
explanation.
first,
Yeah.
and then
Well,
the master key is associated with
Master
that
keys
account,
are
is it
added,
given
yeah,
to
assumably the permissions are all associated with the account. So the authentication just says you are the person who belongs to the account, and then the admin could assign any permissions they want or any privileges they want to the account. So does that answer your question?
The workflow is that the admin will set up the privileges
Right.
for a user. And then that user is given a master key?
No, the user generates their own master key. The user needs to, so just like the ticketing booth again at the DMV, you need to grab a ticket, bring it up, and hand it to the server. There's a cryptographic number that's unique that you sign with your private key and bring back up to the server. And then once you have the private key, or the public key, sorry, you know, the server side can identify this is the same public key that has come to me before. So at that point, you've got a user account, and then you can assign whatever privileges you want to it.
I guess he's asking though, like, if I say like, I need to use Joe in the account, stuff, like, how do I get Joe to sign up when I know what I want public key is Joe?
Right, right. I'd have to. What's that?
You'd have to tell you.
Yeah,
How would you trust it?
you could expire his account, I suppose. I'd have to think about that a little, to be honest. Yeah.
So the question, what's the source of the master key? Where do you get the master key?
From a random source. So you can have your local device use its random number generator.
Self-generate your own master key.
Yeah, absolutely.
Just once.
Yes. Yeah.
The master key is a random, and public key is each time random, right?
Yes. Well, it's derived from the master key and the domain, so it's the same for every domain, but for each domain, it's the public key generated is different.
Yeah. Okay. Master key generated randomly generated one time.
Yes.
Public key generated each time.
Right. Yes. Yes.
Random generated.
Yep.
Okay.
And private key, it's not random, it's once per domain name.
You need to log in, right? And public key is generated each time you log in. It doesn't matter where you log in.
Same each time for the domain.
Per domain, once per domain. Unique per domain.
Yep.
Have you seen the XKCD security one? Number 538?
What was the number?
538.
538. I will see it.
Yeah, you should check it out.
Okay.
It's kind of funny about the whole what's secure and.
Okay. Cool.
So I don't really see too much of a point or concern with, once you look at the QR code and it says, yes, you are logging up to Yahoo. If you're compromised, I mean, likely here, I have no cell phone signal, so I could be on the compromised conference network where both the front page to Yahoo and my phone are going through the same site. It seems like the QR code should be cryptographically signed by a known, like I should have the public key to Yahoo in my phone and validate that the QR code actually came from Yahoo.
Came from Yahoo?
Yeah.
Well, the domain name, I mean, you are relying on DNS to redirect you to the correct location.
Yeah,
that is true.
So weak.
Yeah, it is weak. You know, go on the news group and ask about it. Off the top of my head, I don't have a good answer.
What about requiring DNS crypt? Requiring DNS crypt.
Can't require it these days.
Yeah,
Can't use it? Yeah.
You wouldn't be able to do that.